Trigonometric identities, example 1. We're asked to prove that sec A take tan A times sin A equals cos A. We see that sec theta is 1 over cos theta. We also note that tan A or tan theta is sin theta over cos theta. So we can rewrite the left-hand side of our equation in terms of sine and cos. So sec A is written as 1 over cos A minus tan A is sin A over cos A. And this is multiplied by sin A. Now we notice that each of these fractions has the same denominator, cos A. So we can write them as a single fraction. So this gives us 1 minus sine squared A, because it's sin A by sin A, all over cos A. Now 1 minus sine squared A is familiar to us maybe, because sine squared theta, or sine squared A plus cos squared A, is equal to 1. So if we subtract sine squared A from both sides of this equation, it gives us that cos squared A is 1 minus sine squared A. So the numerator of our fraction can be written as cos squared A. So we now have cos squared A over cos A. Now cos squared A means cos A multiplied by cos A. And this has been divided by cos A. Now cos A goes into cos A once, leaving us cos A. So we've proved the identity. This is the second example, part 2. We have tan theta being multiplied by the square root of 1 minus sine squared theta, to prove that that is sine theta. But we see that tan theta can be written in terms of sine and cos. And again, we notice that 1 minus sine squared theta is related to that sine squared theta plus cos squared theta is equal to 1. So if we subtract sine squared theta from both sides, it gives us that cos squared theta is 1 minus sine squared theta. So now we can rewrite the left-hand side of our equation using these two facts. So instead of tan theta, we write sine theta over cos theta. And this has been multiplied by the square root of cos squared theta. So this gives us sine theta over cos theta. Now the square root and the square kind of undo each other here, so we're left with cos theta. And cos theta goes into cos theta once, leaving us with sine theta as our solution.